atoms. So what do we know about atoms? We know that atoms make up everything. Yes, everything that we see around is made up of atoms. So let's read the points in here. Everything you see around is made up of atoms. The atom is the basic building block for all matter in the universe. Atoms are extremely small and are made up of few even smaller particles. The basic particles that make up an atom are electrons, protons, and neutrons. Electrons, protons, and neutrons. Atoms fit together with other atoms to make up matter. Yes, we know that the matter is the basic fundamental of everything. Yes, atoms last a long time, in most cases forever. They can change and undergo chemical reactions, sharing electrons with other atoms. But the nucleus is very hard to split, meaning most atoms are around for a long time. What it means is, we just learned that there are electrons, protons, and neutrons, yes, in an atom. But the electrons, they can undergo chemical reactions. They can leave the atom. Some electrons can be added to the atoms. But whereas as far as the nucleus, it doesn't move. It's gonna stay. The nucleus, that's what we read here. But the nucleus is very hard to split. Okay. So let's move on to the next slide. The protons. Let's go in a little depth about the protons, electrons, and neutrons. So what do we know about protons? Protons are the positively charged particles that are found in the center of the nucleus. The protons and neutrons basically together make up the nucleus. And the neutrons, just like the name suggests, they do not have any charge basically. So they have a neutral charge. Whereas for the electrons, you see that it's made up of negative charge. So that's a little bit detail about the proton, neutrons, and electrons. If you guys want more, you can just pause this video and take the notes. Moving on to the next slide. There are different kinds of atoms based on the number of electrons, protons, and neutrons that each atom contains. Yes, for example, if an atom has just one electron, that atom would be a hydrogen atom. And if an atom has 6 electrons, that atom would be a carbon atom. If an atom has 7 electrons, then that atom would be a nitrogen atom, and so on. So what we see here is the number of the number of electrons or protons or neutrons are what makes each atom unique. Yes, each atom is unique because of the number of electrons in that particular atom. Yes, so if it has 6 electrons, it cannot be named hydrogen. Yes, it will be carbon. That's the point in here. So moving on to the next slide. Terminologies to know before we proceed further. Element has many same kinds of atoms. Okay, many same kinds of atoms make up an element. Here if you see 2 hydrogen atoms or 2 oxygen atoms, all those will make up an element. Similar atoms should clump together to form an element. That's what an element is. Next we'll move on to molecule. Many different kinds of atoms make up a molecule. So this has got different kinds of atoms. Yes, a molecule can be different kinds of atoms or different kinds of elements together. Does that make sense? An element is the same kind of atoms together, whereas the molecule would be different kinds of atoms or elements together. Okay, and a compound would be 2 or more elements or molecules make up a compound. Does that make sense? 2 or more elements or molecules make up a compound. For example, H2O is one molecule of water. If you take a jar of water, that would be a compound because it has got millions and trillions of H2O molecules in it. Yes. Moving on to the next slide. Elements arranged in a periodic table. So there are up to 118 elements. Hence the scientist called Dmitry Mendeleev in 1869 came up with an idea of periodic table. He began collecting and sorting elements in rows and columns based on their chemical and physical properties. So it would be difficult to have a track of the number of elements, yes? So what he did is he arranged these elements in a periodic table in rows and columns. Okay, so what is a row? Rows in the periodic tables are called periods. If you arrange something horizontally, that's a row. All this is a row. As one moves from left to right in a given period, the chemical properties like the flammability, toxicity, acidity, and reactivity of the elements slowly change. If you move from left to the right, you can see that the physical and chemical properties are changing. Columns in the periodic table are called groups. Elements in a given group in the periodic table share many similar physical and chemical properties. So what's the difference between groups and periods? In periods, the physical and chemical properties are going to change, whereas in groups like these, the physical and chemical properties are going to remain the same. Here we have an example of group 1. So if you can see, it's marked here, group 1. All these are in group 1, this column. So what are all included? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. All these are kind of soft, shiny, low melting, highly reactive metals which tarnish when exposed to air. So that's a physical change, yes? All these are low melting metals, highly reactive metals. So they have been arranged in one column. So it's the similar. All these columns are going to have similar physical and chemical properties. One more example would be this column. These are inert gases, similar physical and chemical properties. That's why they are arranged in a group. Okay. So moving on to the next slide. The elements are arranged in order of increasing atomic number. If you see here, they are arranged in increasing atomic number from the left to the right. What's an atomic number? The number of protons in a nucleus is called the atomic number, and always it's equal to the number of electrons in the orbit. Okay, so here in any given element, that's how you'll represent it as. The atomic number will always be written on the top left corner. So if you see any element, by seeing the top left corner, you should be able to tell that that's the atomic number of that particular element. Okay, so what did we learn in here? The protons and electrons are always gonna be the same in a given atom. Moving on to the next slide. What's an atomic mass? Atomic mass is the sum of protons and neutrons in a single atom. Okay, so in here you see that there are 6 protons and 6 neutrons. So the sum of the protons and the neutrons would be 12. So the atomic number is always gonna atomic mass is always gonna be written on the bottom of a given element. Moving on to the next slide. What's electronic configuration? Electronic configuration is the way in which an atom's electrons are arranged around its nucleus. Way in which atom's electrons are arranged around its nucleus. Niels Bohr's theory of the atoms tells us that electrons are not located randomly around an atom's nucleus, but they occur in specific electronic shell, as you can see in here, an example. Each shell has a limited capacity for electrons. As lower shells are filled, additional electrons reside in more distant shell. Means as the lower shells are filled, the additional electrons will be taking the spot in the next shell. The capacity of the first electron shell is 2 electrons, and for the second would be 8, and it keeps increasing as you move on. Why it's important to know about this? It affects the property of the atom, thereby changing the property of an element. Moving on to the next slide. So you can do a small exercise in here. Draw the atomic structure of a hydrogen atom and an oxygen atom. So remember I told you should be able to tell that the atomic number, where will we find it? It's on the top, yes? So the atomic number for this hydrogen atom is 1. So we'll have to draw an atom with 1 electron. How will we do that? And for an oxygen atom, the atomic number is in here. All the atoms have atomic number written on the top. So now let's see how to draw a hydrogen atom. So what is the atomic number for hydrogen atom? It's 1. If you see in the periodic table, you'll see it as the first element. So you'll start with a nucleus and then you'll draw the first orbit. Since there is just 1 atomic number, you're going to draw just 1 electron. So that's a hydrogen atom. Another example of another element, an oxygen atom. If you see what's the atomic number in a periodic table, you'll see that it's 8. So we'll start with a nucleus and then we'll first draw the first orbit. It can hold the maximum of 2 electrons. That's the maximum, yes? So there are 6 more. So we'll draw another orbit. That's the second orbit with 1, 2, 3, 4, 5 and 6 with 6 electrons. So it has to have 8 electrons, yes, for it to be maxed out. But here you see that there are just 6 electrons in its outermost shell. So it's not maxed out. With more atoms. Another element, okay, another example of one more element. Sulfur. Refer the periodic table and tell me what's the atomic number for sulfur. So that would be 16. Yes, we'll start with a nucleus, 2 electrons in the first orbit, but because that's the maximum you can do in the first orbit, and then the second orbit can hold up to 8 electrons, no more, because that's the maximum that the second orbit can hold, and the rest we'll be drawing it in the third orbit. There are 6, yes, 1, 2, 3, 4, 5, 6. So now that we saw the different atoms, how to draw different atoms based on their atomic number, let's see what it means stable and unstable atom. So while we were drawing, we saw that if there some atoms, they just have 1, the entire shell does not get filled up to its max. It's not maxed out basically, yes. For example, this hydrogen atom has only 1 electron. We drew that, yes. So this atom, we'll consider it as unstable atom, okay. And this atom, whereas the helium, it has got 2 electrons. So remember, with the first shell, we can hold up to 2 electrons. That's the maximum it can hold. So this helium atom would be considered a complete stable atom. Moving on to the next slide. So since this hydrogen atom is unstable, it needs 1 more electron for it to be stable. All the atoms that you see, or all the atoms that we learn about, they always are in this constant process of becoming stable. So this hydrogen atom, since it's not stable, it needs 1 electron to be stable, whereas this helium electron is already stable. So now that we saw that the hydrogen atom wants to be stable, what it does is these atoms, the unstable atoms, they react with other elements so that they can somehow become stable. Okay? But whereas the atoms like helium, which are already stable, they do not react with any other elements. Understood? Moving on to the next slide. So helium was one example of that stable atom. Yes, there are other stable atoms that have been arranged in the top right corner of the periodic shelf. Here you can see helium, neon, argon, krypton. All these are called inert gases. All these are stable atoms which have been named as inert gas. All inert gases are stable, hence they do not undergo any chemical reactions. Understood? What does valence electron means? Valence electrons are the outermost shells of atom and are able to interact with other atoms to form chemical bonds. Remember, while we were drawing the structure of an atom, we saw that the shells were not maxed out. So those electrons that are in the shells that are not maxed out are the valence electrons. Moving on to the next slide, valence electrons are the most important factor for any chemical reaction to happen. These electrons help the atom to react with each other. So that's how an atom can become an element, and an element can become a molecule, and a molecule can become a compound. Okay? So we did see in the beginning of the class about elements, molecule, and compound. Yes? So these valence electrons are the ones that are helping an atom to be an element or a molecule or a compound. Moving on to the next slide. What's a chemical reaction? In any chemical reaction, it occurs by the giving, accepting, or sharing of electrons between atoms. What's a chemical reaction? It's giving or accepting or sharing of electrons between two atoms, two or more atoms. So let's move on to the next slide. We are going to see different chemical reactions that make up an element or a molecule or a compound, starting with an element. For example, you have a nitrogen atom in here, N atom. This N atom has 1, 2, 3, 4, 5, 6, 7. 7 electrons, yes? So we'll arrange the first 2 electrons in the first shell and the remaining 5 electrons on the second shell. So is this a stable or an unstable atom? Yes, this is an unstable atom, yes? So since it's unstable, it's going to react with other atoms so that it can become stable. So what it'll do is, it needs 3 more extra electrons for it to be stable. Yes, because there are 5, 1, 2, 3, 4, 5. It needs 3 more electrons for this shell to max out and for the nitrogen atom to be stable. So what it does is, it's going to share 3 electrons from another nitrogen atom. So now if you count 1, 2, 3, 4, 5, 6, 7, 8. So now this atom has 8 electrons in its outermost shell, and now it has attained the stable state. And also now the other atom that it's sharing with also has 8 electrons on its outer shell. If we count 1, 2, 3, 4, 5, 6, 7, 8. So now even this atom is in a stable state. Okay, so for an unstable atom, it reacts with other atoms to become a stable state together. So now that's a element getting formed. Yes, 2 similar atoms together is an element. Remember, 2 similar atoms together is an element. Unstable nitrogen atom reacts with another nitrogen atom to form an element, N2, nitrogen. Remember, this is the gas that's abundantly found on the atmosphere. We had learned that in the chapter atmosphere. gas we abundantly see in the atmosphere. That's around 78% of the air. That's a extra note for you to take down in your notes. And now we're going to see other examples of elements. We can draw structures of hydrogen atom, nitrogen atom, oxygen atom, and fluorine atom. If you can draw them by yourselves, then it's great. If not, I'm going to explain how we have to draw them. Next, moving on to an example of molecule formation. What's a molecule? Remember, we talked about molecule when two different elements and atoms come together, that makes a molecule. Here is a perfect example for a molecule. You have an oxygen atom. We drew this already. Yes, it has 6 electrons on its outermost shell, so that makes it unstable atom. We need to have 8. So what this oxygen atom does is it reacts with this 2 hydrogen atoms. Even they are unstable because they have just got 1 electron. So they are basically gonna share one electron from each of this atom. This in here and this in here. So what happens? They undergo a chemical reaction and now they form one water molecule. If you see in here, this hydrogen atom now has become stable by sharing 1 electron of that oxygen atom, because the first shell, the maximum is just 2 electrons. And this is also stable now because it has got 2 electrons in its first shell. And this oxygen atom is also stable because it has got 8 electrons in its second shell. 1, 2, 3, 4, 5, 6, 7, 8. Yes, understood? So that's how one molecule is formed. Now that one molecule has formed, one molecule of H2O is a molecule, and then trillions and millions of water molecules put together will be a compound. So if that's one water molecule, a jar of water would be a compound. Okay? Another example for the formation of molecule would be sodium chloride, wherein a sodium atom with 11 electrons, you see here that it has got 2 electrons in the first shell, 8 electrons in the second shell, and now that the second shell has maxed out and there is still one more electron which will occupy another shell, third shell. There's just 1 electron in here. And for chloride atom, it has got 17 as the atomic number. So you'll start by drawing 2 electrons in the first shell, 8 electrons in the second shell, and remaining there are 7 electrons in the third shell. So it's 1 atom less in chloride. So what will happen is these both will react together. What the sodium atom is gonna do is it's just gonna shed this extra electron and give it to the chloride atom. So when that happens, this sodium atom gets stable because this shell will resolve and this will become the outermost shell. So 8 electrons in the second shell means this atom has become stable, and that extra atom, when it fits in this chloride atom, this chloride atom is also gonna be stable. That's what makes a salt, sodium chloride, NaCl. If 1 grain of salt is an element or a molecule, then a jar of salt would be a compound. Yes, 1 NaCl grain is a molecule, then a jar of it would be a compound. Moving on to the next slide. So there are 3 different kinds of bond formation in between atoms. First is the ionic bond, which is the strongest bond, wherein one atom drops its electron to make the other atom stable. One electron has stronger attraction for the electron than the other and steals an electron from the second atom. Oppositely charged electrons stick together. Okay, I don't know this. Okay, so that's an ionic bond. It has got the strongest of bonds. Another bond would be the covalent bond, the one that we saw where in the water molecules that the covalent bond forms by sharing of electrons. What's a metallic bond? Metals are happy to share atoms. Hence, when there are a bunch of metallic atoms together, they create a cloud of electrons, which they share together and stay communal this way. There is an electrostatic attraction between electron clouds and the metal nuclei. This nature of the electron cloud is what gives the metals this physical property of malleability, that's you're able to bend it, thermal and electric conductivity. How does the thermal and electricity conduct through the metals? Because of these electron clouds. They help in conducting electricity from a metal rod. Moving on to the next slide. Yes, I think we have done with atoms, and a small homework that you can do is print out a sheet of periodic table and color the different elements in it. Like for example, metals, color them in blue or whatever color you like, and the inert gases in this corner, color them with orange and whichever color you think is good. So if you do that, you'll get to know how the elements are arranged across the periodic table. Thank you.